Okay, so welcome again for this panel session. This panel session is going to be around emerging technologies, strengths, weaknesses, and market trends. And we have an amazing set of panelists. I'll go back to my document. So we have myself, Valentina Donzella, from the University of Warwick, Queen Mary University of London, moderating. Then we have Pranit Nelapati, technical specialist on AV radar and sensing from General Motors. Thank you very much.
Hi.
We have Fritz Kreiner, VP Engineering, SIG Thermal. Thank you. We have Anas Chalak, Market Technologies Analyst at YOLO. And then we have Dirk Schulte, R&D Director, Advanced Engineering and Product Platform from Value Brain, North America. Thank you very much, guys, for participating in this panel.
Thank you.
And we can start with some questions and discuss them, and then we can also open the questions to the floor and see if there are any further points of discussion. So the first question that I would like to ask is, our cost regulations and OEM priorities influencing sensor selection? And this is for you, Pranit.
Yeah, hopefully everyone can hear me. Thank you so much for being here. So from an OEM standpoint, talking about regulations, in the recent past, the FMVSS 127 has caught all of our attention in the ADAS community. Everyone is scrambling to make that work. So we definitely are looking at a lot of these problem sets to give us something from all the sensor modalities to give us the minimum viable system that can make it work. But the challenge is the global regulation scope across the world is also changing very rapidly. The problem is everyone's intent of what is important for their community is very different. You're seeing someone who's focusing more on the pedestrian side, someone who has more intersection problems, and someone else has like a pedaling bikes who are now the bigger concerns of their safety cases. And the regulators are also believing that these ADAS systems are a really good one-way shop to kind of solve a lot of these concerns. So they're putting more emphasis on these ADAS systems and sensors to take up the responsibility. And as we see this, they're also kind of like scaling up in terms of how effective they need to be. Some of these regulations, they started off pretty mild, but nowadays it's like, hey, you have to be really good at what you kind of do. So this is becoming a really big challenge for a lot of our OEMs. So meaning not like looking at the sensors in an MVP standpoint may not be good enough. We need to start looking at what can this technology actually do in terms of the bigger impact. Like, how much can we push before we can say that this is good enough? But the bigger problem also is, while we are trying to do, there are the two bigger things that most of the OEMs and maybe the suppliers are also worried about is the cost. Mm-hmm. Everyone wants to optimize the cost. They want to do it as cheap as possible. But at the same time, they also want to get to the market first. The time to launch is extremely important. A lot of our OEMs are trying to really condense the vehicle timeline. So we are trying to balance these things very much. So this becomes such a difficult thing for most of us because the sensor development timeline has always been a little slow compared to our market expectations. So we are actually, that's where while we are trying to do the sensor selections or other engagements, we are trying to work very actively with our partners early on to understand what can we do to integrate this into the OEM systems in a very efficient way, in a fashion that we understand the limits, so there is no surprises coming down the road. So that's how I look at this, the landscape for it. I don't know anyone else have any comments on that. So
I know there's one aspect of the NHTSA regulation is really pushing for software updates.
Right.
And certainly that's, I think, the dream or the hope that you can just do this with a software update.
Right.
But is there, I guess, maybe from your perspective, do you see that as a possibility to get to actually beat the FMVSS 127?
Definitely. I think this is all, that's where like a lot of people are counting on the over-the-air upgrades, right? But the bigger problem is we still need the hardware to be ready.
Yeah.
So that's, I think, the biggest challenge that all of us are looking into. So the hope is, hey, if the sensors have the capabilities, maybe eventually all of us can figure it out. But can we do that in a more timely and a cost-efficient way? That became the challenge. So.
You mentioned cost as well. Do you think we are going to go towards minimal specs for the sensor suite and then move from there, or do you see everyone implementing their own?
Definitely a lot of customization is happening because everyone, see, that's where this ML really kind of changed the landscape, because in the classical architecture, I believe most of the people were looking in the same search space. Now everyone believes their approach is the best. So I know a lot of my collaborators, they are getting a different request in terms of what works for them. So that's where I think there is a lot of similarity that they want to hold on, but they also want to customize it to integrate very well into their system. So I think the challenge is becoming for, our product teams, where they have to develop these separate paths for different requests. So.
Any more?
Perhaps just one comment on what Praneeth mentioned with regards to the FMVSS 127, because that has become a really interesting test case almost for our industry, and it has caused a collective panic in the industry somehow. And the interesting thing is, I think all the actors are pretty reasonable in their approach, because when you just look at the FMVSS 127 itself and you just want to be compliant with the rules, it's actually not that difficult, but it's very synthetic and not really real-world test scenarios. I mean, just go on a test track and brake. I mean, okay, everybody can do that with a minimum, as you said, with a minimum sensor set. But what the OEMs are really looking for is they have to be able to sell their vehicles. And if the vehicle is compliant to FMVSS 127, but reacts completely erratic on the road and makes really crazy things, nobody's going to buy the vehicles anymore. So they are looking actually beyond the FMVSS 127, beyond the regulation, to create a sensor set and a technology that covers the regulation, but also permits a reasonable driving behavior. And I think the real problem lies there, not just in the regulation compliance itself.
Yeah.
And that drives then also the decision with regards to the sensor set.
Right.
Any comments
I kind of agree with them, all of them, with Dirk also. I don't have too much to add, so yeah.
Yeah,
Okay.
on that note, like, I think Dirk brought up a really good point, because I think on that note, we also want sensors who can actually transform depending on the cases, right? It's
Yeah.
not just like we want to tie the sensor to one particular feature.
Yeah.
A lot of things are coming up. We want our sensor
Absolutely.
to actually transform to that.
Yeah.
So, sure.
Okay, thank you very much. I think related to that, we can also move to what are the market trends and how they influence overall the assisted automated driving environment, in your opinion, Anas?
Yeah, so completely also what Praneeth said about regulations. So for me, the main two drivers are the safety and the regulations. So we are looking into more autonomous driving, more safety to make sure to implement more sensors. And then I think the market dynamics also is very important to see what's happening, for example, in China and the rest of the world, because it's kind of different. So if you look at China, for example, you see that Chinese OEMs are implementing more sensors than in Europe or in the US. And that comes also that like some changing in the dynamics in the ecosystem. Like there is many tier 2, like they were just optic suppliers. Now they provide the camera with the cheaper. They work with OEMs. So OEMs like BYD, they announced recently that they will implement 11 cameras minimum per car. And then the trend is to implement more and more sensors, which is really pushing the industry to implement more sensors, even radars, even LiDARs. If you look to the LiDARs price, the ASP of LiDARs is dropping really fast in China. So for me, I would say that's one of the reasons also that we are really experiencing a boost and more implementing of different types of sensors per car. I don't know if you have an opinion, yeah.
No, I sympathize with that, and definitely again, some of these conditions are kind of also very fluid. It depends on so many other factors coming in. But primarily, we definitely want to keep our sensor set to be as optimal as possible, both from a hardware side, but at the same time, as Dirk was mentioning, how do we scale up, right? Scalability is a huge problem that if you don't encounter that upfront, could be a problem down the road for us. So.
Anything else?
Have you seen any kind of, you were talking mainly LiDAR, cost down to LiDAR. Have you seen any thermal imaging advancements from your perspective?
Yeah, in China there's some OEMs that they implement still like thermal cameras. The main application is still for night vision. Also, as you mentioned, like for with the regulations, maybe for if there's the need for automatic emergency braking, this could be really the chance to implement more thermal cameras. But also, I would say it's going to be a challenge because like if the price of the LiDARs will keep dropping, compared like with the LiDAR and thermal cameras, what will be the best combination? I mean, we will have like many combinations of sensors, but I would say that it really depends because with the LiDARs and the camera, you can have the depth sensing, and at the end of the day, you can achieve the function. And as Dirk mentioned also that to really meet the requirements of the regulation is not that hard at the end of the day. So I think it's gonna really depend. But for the moment, still thermal cameras are limited for like I would say premium night vision options in cars. Yeah, and the chance is like really with the regulations to have like we're like talking now about thousands of like hundreds of K units. And now with the regulation will come, maybe this will really boost them in the next 5 years.
Yeah, I agree.
Do you see any other technologies emerging in
Actually,
automotive?
yes, on the sensor level, if you look, for example, we're now talking like also OmniVision mentioned in the like morning session about the event-based sensor, for example, to minimize even the like the low to have low power, minimal low power, minimum data image sensors to be able to have lower latency also, and so event-based is one of the or neuromorphic sensing is one of really the technology that we should keep an eye, I would say, on it. Thermal imaging also, I would say, is one of the technologies also that are emerging, and yeah, I would say what's nice is that you feel always that there's a hunger towards more like I would say improvement and emergence of new technologies in the market, and that's really positive.
Can I touch on one point? You mentioned that the problem of data and so on, which is one that I really care of because it's related to some of the research activities that we carry out in our group. Do you see a problem in the future with the data that is produced by the sensor suite, and how do we make data sustainable for autonomy?
Yeah, that's a good question. It's hard to say. I don't know if I'm qualified also to say, but yeah, that's also one of the reasons that when we talk about, for example, event-based sensor, like because we generate a huge amount of data, sometimes more than we really need for some applications, and it's going to be really complicated for computing after processors, how it will be to have all of these sensors together and to be able really to have fast response and to be able to manage all of this data. So yeah, it's really hard to say. I don't know what's the best solution will be, but I think it's really a real concern for the future.
Any comments on that?
I mean, with regards to the data and the data generation, perhaps the exterior sensor space can learn something from the interior sensor space, I think sometimes. Because for the exterior sensors, it's very easy to just go on the road to drive and to collect data, I mean, without end, and in the end not even knowing what to do with that, and most of that is not significant because nothing is happening.
Yeah.
In the interior space, it's much more difficult to do this kind of thing, and the people who are dealing with interior sensors, they are much more used to create corner cases and specific situations that really validate or test the sensors in the really critical situation. And I think that is perhaps an interesting thought, how we could limit the amount of data that we are actually collecting and then make it more meaningful by concentrating really on corner cases and on critical cases. And that's something that is more common or perhaps easier to do even on the interior sensor space.
Yeah, I kind of agree on that because the late fusion approaches on a lot of AI/ML allow that flexibility for the sensors to be different and kind of plugged in at different points.
Yeah.
But as most of the industry is moving towards early fusion, kind of like low-level data integration, is creating a lot of complexity because most of that data cannot be reused. The minute you change one small point, now it's kind of dragging the entire dependency of that.
Yeah.
So again, I don't know what is the right solution for it. Maybe the synthetic data could solve our problems, but I see still a lot of skepticism, around the industry for that.
Yeah.
Yeah. Absolutely. Thank you very much. So moving to another question. Fritz, in your opinion, which technologies are poised for widespread deployment and which face barriers for scalability?
Sure. I mean, I think we all know, cameras, radars are here to stay, and we're going to still continue to see advancements in camera. We're seeing more and more megapixels. We see camera with higher and higher resolution, going to 4D cameras. And I think really the emerging technologies, and of course LiDAR, we've seen the big boom and maybe it's now settling out. I mean, LiDAR still has some settling to do within, is it direct time of flight? Is it FMCW? What are the scanning ways? So I think within that technology, there's still some settling that needs to happen. But we do see, and especially I think as mentioned in China, cost is coming down. However, there is still a kind of a size, weight, power constraint for LiDAR, and maybe the cost is being addressed. And now with thermal that we are into, we saw a compelling case earlier from the talk before this.
Yes.
I mean, it's a compelling case that thermal does meet FM VSS 127. It can fulfill that use case at a reasonable cost. So we certainly see that as an emerging technology that's able to scale based on the kind of supply chain. So it's certainly part, and I think we see it more and more, part of the sensor stack. You're not going to have necessarily one sensor to fulfill, or two sensors to fulfill all use cases, but you'll have a sensor stack which would have camera, radar, LiDAR, and thermal to really address all of the various corner cases necessary.
I mean, part of the answer is definitely that each sensor has its own field and its own strengths, as it has its own weaknesses.
Yeah.
And there's actually a reason when you look at robo-taxis like the Waymo, for example, it is full of sensors and there's a lot of redundancy. And the higher you want to go in the automation, the more sensors potentially you need and the more redundancy you need to provide. So I'm not sure if there are really sensors that we could call the dinosaurs and they're poised to die out. And I don't think that that's the case. It really depends on the level of automation, on the function that you want to achieve. And there's, to some extent, place for everything. And it depends also a little bit on what you can afford, actually. They are, again, robo-taxis, they have certainly the means to afford more expensive sensors and put them on the vehicle. When you think of platooning applications for commercial vehicles, they can also afford higher level sensors. If you have a $20,000 entry level vehicle, not so much. I mean, it's really, I think there's place for everybody, and it depends really on the vehicle, on the level of automation that you want to demonstrate or that you want to achieve with your vehicle.
You all have mentioned radar as a sensor which is going to stay, but do you think radar is going more towards 4D radar or imaging radar, and do you think at that point it can be a proper competitor of LiDAR?
Okay, so personally, I definitely have a slight, vanity towards radar, mostly working on the product, but yes, definitely 4D radar is becoming more mainstream for a lot of applications. And definitely we are seeing the trend of even a lot of collaborators are actually trying to push the boundary. They want to go upscale in the frequencies, they want to try to get better resolution. Maybe, I don't know if it can solve all the LiDAR problems, but there is definitely a lot of effort that is being seen to find a common path, because there is also a lot of advantages that people are saying that they will see from a ML standpoint, especially the perception stack, because right now the biggest challenge is radar deserves its own path.
Yeah.
Unfortunately, like optics, they have a lot of shared ecosystem, and there is a lot of effort to say, hey, can we bring this together to create a common ecosystem? So, yeah.
Do you think there is more work to do on the software side or on the hardware side?
Hardware, primarily because of the regulations, but there is definitely a lot of, I'll say, industry know-hows that needs to be shared, because that's one thing that I don't see a lot happening in the radar space. In cameras or other things, you have a lot of algos, toolboxes, data sets that are available. Radar is slowly getting there, but I think everyone is trying to hold their cards very close to the chest, which is kind of also making the progress a little late. Yeah.
Yeah, also from a research perspective, I would say we have way more information for LiDAR and camera than what we have for radar, and getting data out of the radar that are so processed makes it difficult then to be able to manipulate this data in a meaningful way.
Exactly, and also it doesn't also help that it's not easy to visualize, right?
Yeah.
So,
Any more comments or points? No? Okay. So now, Dirk, starting with you, what are the next breakthrough technologies in the next 5 to 10 years, in your opinion?
Okay, so I have to take out my crystal ball and
Yes.
I guess. I mean, perhaps the short answer is, I don't know. I mean, there's a couple of things that are still coming. And we touched on that already, a 4D radar. Praneeth mentioned higher frequency radars. We are going into 140 gigahertz. We're going even higher than that. I mean, some people are talking about terahertz radars. There is evolution there. We have different camera types. The infrared camera, or the LWIR camera, is not that new, but I mean, perhaps one of the newer players in the market, and there's still evolution to come there. Higher resolution. I mean, they're going from VGA to 1 megapixel to more than that. So there's things to come. But I think globally, when you look at the physically speaking at the electromagnetic spectrum, I mean, we have covered basically everything that is usable, right? I mean, there are improvements that are coming. There is certainly convergence, so putting sensors together, trying to solve the packaging issue by bringing sensors closer together. And for example, when you talk about fusion, if you want to fuse a camera, vision camera with a thermal camera, the closer they are together, the easier it is to fuse them actually. And so, I mean, there might be solutions coming up to solve that problem. But I think globally, yeah, we are going in smaller steps. I think now the real big deal is actually not on the hardware side anymore, it's on the software side. And I mean, we are all talking, we all have in mind this nice buzzword, SDV, the software-defined vehicle. But I think that is where it goes to. I mean, we are going to see much more usage, even of the existing sensors, by cleverer software, by implementation of AI, and also by fusion. There's a lot of things that can be done by fusion, and I mean, Praneeth, I think you mentioned that already. There is today, most of the fusion systems that we find on the market, they are late fusion, which is, okay, just comparing, I mean, who of the two sensors has potentially the better answer, so let's take this one. But that's not really fusion, actually. I mean, what we really want to do is early fusion. We want to take the raw data and fuse, for example, a radar point cloud, or even before the point cloud, the signal that we have together with the vision camera signal, that makes something out of that to make a real common decision, a fused decision. And I think that's where the answer lies. And that goes then more also in the compute architecture, away from the separate architectures, going to a centralized compute architecture. And also, let's not forget in that the data transfer, because we're moving away from CAN. Now it's going to FlexRay, it's going to Ethernet, and Ethernet is stepping up also from 10 to 100 giga and so on. I mean, we need really this compute capabilities and the data transfer capabilities to have the sensors communicate with each other to make them better. And perhaps then we don't need so much completely new or revolutionary new sensors, but we can already use the sensors that we have now better and to a fuller degree than we do today, thanks to better compute and algorithm capabilities.
Yeah, I totally agree, in fact, because also even like, as you mentioned, like it goes beyond just going to just the sensor level, because now we have more sensors per car. So I can talk about the camera because it's the focus of my work. Even like now there's a trend, or like we see that they want to implement the serializer inside the image sensor, in fact, to really simplify the architecture. So also many OEMs and image sensor suppliers working on that. So yeah, it goes even beyond just working on the sensor by itself, but just even the architecture of the car, the connectivity, all the data transfer. It's really like more complicated than that.
Yeah, I mean, certainly it's interesting to see the AI together with the sensors. And you know, there was some interesting stuff on radar, and I think as you fuse the data together and use AI, I think it's extremely interesting and powerful. I guess we're going to have to make sure that the AI doesn't hallucinate, as we've heard. But I think I could certainly see that as a future of having kind of smarter connectivity, central compute with AI, with all of the sensor modalities.
Yeah, from a sensor standpoint, I believe, like as Dirk mentioned, as we are going lower and lower to the raw data, there is a lot of new concerns coming up in terms of how to stabilize it, what to do with it, and how to kind of capture the essence of what we are trying to go after. That's actually creating a lot of interesting proposals on the hardware space, things that we never mentioned a few years ago. That that especially adding in terms of some of the IMUs and other things, which is phenomenal. But from a feature standpoint, I think the most exciting thing that I'm looking at is vision-based parking. It is kind of really coming into the scale. So that seems to be pretty exciting in terms of at least the next 3 to 4 years.
So do you see definitely as a trend higher use of raw data and reducing as much as possible the pre-processing?
Definitely, yes, because I think people still believe that we are not using our sensors to its limits. So that's where the focus of kind of going deeper and deeper and kind of closer to the source is where they believe that we can kind of like really exhaust the space. And again, the hope is, maybe the ML will find some patterns that we are all unaware of, and hopefully that will kind of give us some, more enhancements in our feature space.
Okay, sounds good. I think we have exhausted all of our questions. So at this point, we can ask to the audience if they have any questions for this panel.
Everybody is waiting for the cocktail.
Yeah,
There you go.
happy hour.
Don't be shy.
We have a question there.
Can you hear me?
Yeah. Yes.
So my name is Rohit. I'm from Bosch. So we were discussing about sensors in the individual vehicle. And if we look over the trends from 5 to 10 years, my understanding is we'll be more connected. And then we are talking about swarm intelligence. So you're not only looking at the vehicle data of your own sensor set, but you should be able to tap in the information from your neighboring, or I will say within 20 or 200 meters. So what is your take on that? Do you think so it would be coming in 5 to 10 years?
So I believe that you're talking about like adding some of the parts, right? So there is definitely like with the V2X and other things that are also coming, there is a lot of shared data that is definitely being part of this equation, because the problem is for some of these early technology trends, a lot of us cannot pinpoint what the customer might appreciate more than the others, where the trade-offs would like. So a lot of OEMs at least are looking at this connected vehicles in terms of especially kind of how to mine this data and what to look for. So the hope is, again, is we understand what trade-offs that we can live with. So, yeah.
I mean, there is a big problem when we start including connectivity from a cybersecurity perspective, from a latency perspective, and so on.
True.
So
True.
it's true that we add information and possibly the possibility of expand the ODD,
Correct.
but then we start having to face new challenges. So
Yeah, cybersecurity again, like anytime we see that, it's like a huge, hey, we have to be careful here. But yes, a lot of actually hardware vendors are actually coming up with a lot of good solutions to actually provide encryptions at the hardware level. So it's no longer a software solution that they're looking at. So a lot of these capabilities are helping a lot of us, but it's also creating additional complexity for latency because there is a lot of aggressive time limits that are being set on us. So, so that also kind of making a lot of our systems trying to be really smart about what data to send out and how to compress it and how to be efficient in some of that decision models. So, yeah.
And in a way, it changes also the way we approach autonomy, because instead of talking of vehicle as a system, we are starting to approach it as a system of systems
Yes.
with all the complexity
Correct. Yeah.
involved in that.
And I think part of the problem is also, I mean, V2X is actually a very good approach and very fascinating.
Yeah.
And it could even replace other sensors, or almost all the sensors. And if we would stop time and have all the vehicles equipped with telematics and with the V2X system, we wouldn't have any problems anymore on the road. The problem is just that's not possible, and we have so many old vehicles and different aged vehicles, and the mobile device market is moving so much faster than the automotive market. The automotive market is always behind it.
Yeah.
We have so many vehicles that even don't have any telematics inside, or at best they have perhaps a 4G system.
Right.
Everybody has a 5G telephone in their pocket, and now we are talking about 6G. And until this arrives in the automotive industry, the mobile industry is already at 7G or 8G probably. You know, that's, I mean, we are always running behind that trend and too slow. It's going to be very interesting how that plays out. It's a very interesting feature and very powerful. The biggest problem that I see is that the automotive market has a much longer lead time than the consumer electronic market, and is always going to be behind, and we are never going to be able to have a homogeneous distribution of the features throughout all the vehicles, which is necessary to really make it a senseful safety technology. Yeah? If there's one vehicle that is not equipped with that, the system is broken already. Yeah?
Sure.
Yeah. Any more questions from the audience? Yeah.
My name is Shashi from Continental.
Wait.
Hi, my name is Shashi from Continental. My question is overall general consumer trend, right? So in the personal ownership, vehicle ownership, do consumers want L3? Do they want to let go of the control? Or maybe they want to let go of the control, or they don't trust the current systems, right? So how do you see this
Well,
situation?
I mean, I can answer from my own perspective. But certainly, you know, when I'm driving on the highway, you know, I engage, you know, autopilot, and certainly I want that. So, I mean, I think once you have it, I don't believe you can step back and kind of go back to the, you know, horse and buggy anymore. But you know, I think it's kind of for each individual, you know, and do they trust the system? I think there's the big part of that, of how do you have, I think, Dirk might have been mentioning, but you know, about false positives. What's the driver experience? I think if you have a good driver experience, I think you will want it, and you won't look back. But that's my opinion.
Yeah.
So yeah, there's one point, I mean, I have to partly contradict you perhaps, because I fully agree with you on one hand, and I also, I mean, I love my Super Cruise and everything. As soon as I can, I engage it. But we are all engineers, we are all in the automotive space, and we see things differently from probably the general public, if I may call it like this. And there have been studies, actually, a couple of studies on this topic from JD Powers, from IIHS, and so on. And the conclusion to which they came, if I hopefully get this right, is that today the consumers don't see the automation that is available in the vehicles, which is basically level 2 plus. They don't see it as a safety feature. They see it as best as a convenience feature. And that's actually not exactly where we want to go to in the automotive industry, right? We want to go with level 3 and so on. We want to really have the vehicle take over and provide safety, but that's not how the general consumers, according to these studies at least, see it. They see it as a convenience feature. They are sometimes very confused. What is level 2? What is level 2 plus? I mean, not even we know that exactly, because I mean, actually there is no level 2 plus, because that's not an official definition, but it's more like a marketing definition. Yes. But yeah, they don't know exactly what that means and what they can expect from the system, and that's why they perhaps not use it so much. And I mean, our ambition as being in the automotive industry is to make these systems approachable and self-explanatory, if you want, so that they really can become a safety feature that is accepted by the consumers. And today, according to these studies, as I said, IHS, JD Powers, and so on, we are not there yet.
Yeah, I kind of agree. I just maybe can add that I saw a study also that compares like how people reacted if just have a metro, for example, like automation, And then they said, okay, also they don't maybe feel very confident about it, but then once you have it, they just take the metro and they don't think about it and they enjoy it. So I think, yeah, I agree with Fritz. Once you have it, maybe I think people will adapt really, and then, yeah, they will accept because they will use it. That's my opinion also.
I don't know, again, as my opinion, when I went to buy my last car, obviously I was excited, oh, which sensors are on the car, which are, and they are so vague when they reply. I think it's it should be part of the deal to teach customers that these are safety features, there are these sensors, and because it's important at the end of the time to build that trust in the technology. But yeah, I was very disappointed when I asked them which sensors are in the vehicle. They looked at me like an alien. Any more questions? If not, I think I can really thank all of you guys. Thank you very much for the interesting discussions, and I hope it was useful and interesting for you guys as well.
Yep, thank you all.
Thank you.
Thank you.